Thank you, Mrs. Grayback, for that wonderful compliment. And I would have to say, I think the same thing about you. Um, so, what we're looking at here is a sample problem of the ionic bond that would form between magnesium and chlorine, two separate elements, one being a positive ion, one forming a negative ion, and how do those two things come together to form a compound? So, following those steps, I'm going to walk you through and point out some of the things that I want you to be looking at when you're doing these types of problems. Okay, so the first step here says to use the periodic table to identify valence electrons and draw the Lewis dot structure. So when I say Lewis dot structure, I'm really referring to this. Okay, this is some other information that you can be using to get to this point. So this is the Lewis dot structure and this is the Lewis dot structure. These are the two things that you need to be able to create. Okay, and we do that by, remember, using our periodic table. So for magnesium, for instance, it's in group 12, so it has a total of 2 valence electrons. Okay, and remember that valence electrons mean outermost electrons. So, for instance, looking at the number of rings magnesium has. Magnesium has 3 rings because it's in that third period down. In that outermost ring, there's only 2 valence electrons. And that is why its Lewis dot structure looks like this. I remember that we draw these in boxes. It's not like a random circle that goes around. It's a very like 2, 2, 2, 2 when it's all full. But magnesium's not full. Magnesium wants to be full, but it's not. So this is magnesium's Lewis dot structure. In the same way for chlorine, okay, we find chlorine on the periodic table. Okay, chlorine is in group 17. And it's also in that third period down, 1, 2, 3. So it's got those 3 rings, but in that third ring, unlike magnesium, in that third ring, it has 7 valence electrons. So there's 7 total valence electrons for chlorine, 2 in the first, 8 in the second, and then there's only 7, which means that chlorine has a total of 7 dots in its Lewis dot structure. Okay, so these are the two things that you need to be able to draw. You don't necessarily need these lines, so that's why the chlorine's missing them here. You just need the dots. So chlorine's got that 7. Once you have those Lewis dot structures, you can move on to the next step. So let's break that one down. So here's that next step. Okay, determine the ion that would form for magnesium and chlorine. So this is where you have to remember that octet rule, or the rule of 8. It goes by a few different names, but the idea here is that every element wants to have a full outer shell. And there's 2 different ways you can do that. You can either gain electrons to get a full outer shell, or you can get rid of your electrons, and then your shell that came before the outermost is now full. So for instance, magnesium here, this shell is not full. Now, magnesium could try and gain 6 electrons, but that's really, really hard to do. So instead, magnesium is going to just get rid of the 2 that are there. And then that second ring, it gets rid of that third ring altogether, and that second ring is full. It's got the 8. So because it's getting rid of those 2 outermost electrons, now its outer shell is full. It has 12 protons total. So that's from its atomic number. Remember that a magnesium has 12 protons total. But if it gets rid of 2 of its electrons to have that full outer shell, well, now we only have 10 electrons. So we have 12 positive charges and 10 negative charges. So that means that magnesium gets a 2 plus charge, because now we have 2 more positives than negatives. So you need to be able to identify the charge here. Okay? For chlorine, on the other hand, chlorine's going to work a little bit differently. It still wants that 8 electrons in the outer shell. The difference is that for chlorine, instead of trying to get rid of all 7 of these electrons, that's a lot of work, having to get rid of all 7 electrons. So instead, chlorine's going to take the easy road here, and it wants to fill in this blank spot, this does not have an electron. If it did, it would be full. So it's going to steal that electron from some other atom. And by doing so, we now have 18 total electrons because chlorine is element 17, so it's got 17 protons. But if it gains an extra electron, well, now we have 18 electrons and 17 protons. So 18 negatives versus those 17 positives. We have one more negative, so chlorine has a -1 charge. That is how we figure out the charges, is we determine, are we gaining electrons like for chlorine? Because if we gain electrons, we become negative. If you're gaining 1, you become -1. If you're gaining 2, you become -2. If you're gaining 3, you become -3. And if you're getting rid of electrons, you become positive. If you're removing 1 electron, +1. Removing 2, +2. Removing 3, +3. It all comes down to the number of protons versus the number of electrons. That determines your ion. So once we know the ion that forms for those two, we can move on to the third step. And in the third step, we have to determine the number of atoms of each ion we need in order to cancel out the charges. Because remember that ionic compounds are neutral. They have no charge. So when two things form an ionic compound, you should have an equal number of positive and negative charges total. So what does that look like? So if magnesium has a 2+ charge and chlorine has a 1- charge, what that means is that we have two separate chlorine atoms, each with a -1 charge, because they're -1 because they took the electron from magnesium. And by taking those two magnesium electrons, magnesium formed that 2+ charge. And this makes sense because we need two -1s to cancel out the two positives that each magnesium carries. It's kind of like saying this chlorine is short $1, and this chlorine is short $1, and this magnesium's got $2. So I only need one magnesium to give $1 here and $1 there, and then we're all set. There is a short way you can do this too. Once you know these numbers, okay, the charges on an ion, sometimes they're called oxidation numbers. Once you know those, there is a shorthand. If you're given a problem, let's say I have an ion of 2+ magnesium forms with a chlorine with a charge of 1-, and I want to know, hey, what is the compound that's going to form between these? So I have my reactants here, and then my product. The quick thing to do here is okay, well, if I know this is my oxidation number, that gets carried down here as my subscript. And then this is my subscript over here. So this becomes MgCl2. And that's my final answer. Okay? Being able to do this is my final answer, because what this means is that I have one magnesium atom bonded to two separate chlorine atoms. And there is an imaginary 1 here. We don't typically write the 1 when we're writing compounds, but you could put it there. There's an imaginary 1. And this is what that Lewis dot structure for the compound would look like. It would look like a single magnesium element giving one of its valence electrons to two different chlorine atoms. This can be really difficult for students, and if you're having a hard time, remember to come see me during my virtual office hours. The link is posted on the top of Google Classroom. I hope you guys are staying happy and healthy and safe. I hope to see you soon, and let me know if you're having any issues with the practice problems, and we can do a few together when we get to those office hours. Bye, guys.